I want to look at using the ideal gas law to find out something about the density of gases. And the relationship between density and physical properties is density equals mass over volume. And when we first look at the ideal gas law, we might think that we can't use it to do that because we do have the volume term that we need for density, but we don't have a mass term. We don't have something that says grams or kilograms or anything like that. However, we do have this moles term, and we can use that and take advantage of that because there is a relationship between moles and grams. If this mu symbol, Greek letter mu, is equal to the molecular weight, the molar mass of the compound, grams per mole. The molar mass equals number of grams per mole. We can rearrange that so that moles equals the grams over the molar mass, and we can substitute that relationship for moles into the ideal gas law where we have the n of the moles. And that's what I'm going to do right here. I'm going to take it, and where I had n before, I'm going to substitute in grams over molar mass. I'm going to rearrange this a little bit and get it so that I have grams over volume, which is our definition of density. Mass over volume, grams is a unit of mass. And I'm going to substitute in the D for density where we had grams per volume, and we get a relationship between pressure, molar mass, density, and temperature, or as I like to abbreviate it, PM equals dirt. And we can use that relationship to solve things involving the density. For instance, if we look at this problem, what is the density of carbon tetrachloride at 714 torr and 125 degrees Celsius? We can rearrange our PM equals dirt equation so that we solve it for density. I accidentally used a small d here. I'm going to keep it consistent and use the large D here. Density equals pressure times molar mass over RT. And the first thing we need to do actually is convert our torr into atmospheres. So we're going to take our pressure in torr, and we're going to multiply it by 1 atmosphere per 760 torr and find out that that equals 0.939 atmospheres. We substitute into our density equation, and I notice again I use the small d again to keep it consistent. I'll change that to large D. And 0.939 atmospheres times 154.0 grams per mole divided by the ideal gas constant in the temperature in Kelvin. And when we solve that, we find that the density comes out to be 4.43 grams per liter. And you'll notice that's an important thing to keep in mind, that when we're talking about density of gases, the units are in terms of grams per liter, which is a little bit different than when we talked about liquids when it was in terms of grams per milliliter.